Today we're going to touch on slope fields. We will come back to them again near the end of the year, but for now I just want you to be able to draw one and kind of know what they are. What a slope field is, it's kind of like a weather map or a magnetic field. It kind of shows you the slope at a different point, so at each individual location. Let's practice drawing a slope segment first. So if I need a slope of 1 is like 1 over 1, so a slope of 1 would look like that. Slope of 2 is 1 over 2, so it would be up 1 over 2, so it would end up looking something like that. Pause the video. Try a few more. The rest of these on your own. We'll check them in a second. Now that you've given these a try, up 2 over 3 should look something like this. Up 2 over 1 should look something like this. Up 3 over 4 should look something like this. And 1/6 should look something like, oh, even smaller than that probably. So those are just little chunks of slope. On a slope field, that's what the entire graph is touched with. So this dy dx is our slope. We're going to find the slopes by plugging the x into these values. So if x is 0, 0 plus 1 is 1, so everywhere where x is 0, we have a slope of 1. When x is 1, we get a slope of 2. When x is negative 1, we get a slope of 0. So you're plugging in your ordered pair at every location until you can get all of these slope lines drawn. And that's a slope field. We'll do more math with it later, but for now, that's the slope field. I'm going to skip around a little bit. 2y only uses the y coordinate. Move on to the next page. Negative y over x involves both. So, for instance, I like to look for patterns. Anywhere where x is 0, it's going to be undefined, which means it's going to be a vertical line, and that would be all of these places. So kind of look for trends. Anywhere where y is 0, negative 0 over anything is 0. Where y is 0, scratch that last one. Where y is 0, we're going to have horizontal slope. Then for the rest of these, we plug them in. Let's say we plug in 1, 1. We're going to get a slope of negative 1. And if we plug in all of these points, we're going to get slopes similar to this. And you can kind of see trends as you do these. You should spend some time thinking about them. Don't just copy off what I'm doing. So there's the slope field. Finish up the 4 that I skipped on the back of that front page. Do all 4 of those. This entire note sheet should be filled in when you get to school tomorrow. So, number 6, this one was interesting. It says, consider the differential equation dy dx equals x squared over y minus 1. On the axis provided, sketch a slope field. So, again, I like to look for trends. What's going to happen when y is 1? Well, when y is 1, we're going to get 0. When x is 0, we're also going to get 0. So that means 0 slope at those 3 locations. And these other points we might just have to plug in. For instance, 1, 0. 1 squared times 0 minus 1 gives us negative 1. Negative 1, 0. Negative 1 squared times 0 minus 1 is negative 1. Plug in 1, 2. 1 squared times 2 minus 1 is a 1. Same thing here, because negative 1 squared is the same as 1 squared. 2 squared, for the point 2 times, no, sorry, 1, 3, this point here, 1 squared times 3 minus 1 is a slope of 3. Same thing we're going to get over here with a negative 1 squared. So there is our slope field. Now, it asks, while the slope field in part A is drawn in only 12 points, it is defined at every point in the xy plane. Describe all the points in the xy plane for which the slopes are positive. And that would be everywhere where y is greater than 1, but there's a catch. Because when x equals 0, it's 0 slope. So we can't include where x equals 0. So everywhere where y is greater than 1 and where x is not equal to 0. Get good at being able to do that. That shows up on the AP test very often, especially if they give you a slope field question. So finish up those slope fields. We will talk about them tomorrow.